Michael, you can start whenever you're ready.
Have you ever wondered what it was like to be around in the beginning of the solar system? Well, NASA has, and they decided to do something about that. NASA sent up the Dawn mission to orbit dwarf planet Ceres in March of 2015, and this has a mission to study this more primitive asteroid. These primitive asteroids can give insight into the early solar system and tell us a little bit about how terrestrial planets formed. And that's because primitive asteroids can be used as building blocks for planet formation. Now, to better understand these primitive asteroids, it's best to inspect the impact craters that are seen on the surface. Impact craters are used as windows into the past to see what might have happened on the surface or what could be happening currently on the surface. So I investigated 44,000 craters on the surface of Ceres using the Dawn data, and I analyzed these craters and categorized them into several categories, but the two that were most important were preservation and crater interiors. The reason why preservation is so important is because it can give us an insight into the age of the surface, and the interiors can tell us about the strength of the crust. So let me explain a little bit about why the preservation is important. So we know that it can give us age date, but how do we do that? So we look at the impactors and we see if a body is heavily impacted, we consider that an older surface. If a body has a minimal number of impact craters, then we know that it is very young. For example, if we look at Earth, it has very little impact craters, so we know that it's a younger surface, and that's because tectonic activity, glacial activity, and weathering erase these craters over time. Ceres, on the other hand, has a very heavy population of craters, which means it's quite old. This means that the surface has remained unchanged since almost its formation. So, by taking that information, we can now look at the interiors and find out what happened during the early solar system. So now we can look at two types of features, central peaks and central pits. Central pits are subdivided into two categories. We have floor pits and summit pits. Floor pits are seen on icy bodies, and they're at higher frequencies, whereas central peaks are only seen on rocky bodies. Summit pits are seen when we have a combination of an icy and rocky body, and there's some sort of weathering that's occurring on the surface or underneath the surface. Ceres exhibits all three types of interiors, which means that there's some weakening of the crust, which is interesting because central peaks are populated across the entire surface, whereas floor pits and summit pits are seen in the northern hemisphere, which is an indication that the northern hemisphere is weaker than the southern hemisphere. With further investigation, it can give insight into the early evolution of Ceres and its formation, as well as early insight into the early solar system. Thank you.